So my name is Jim Kreft, and I'm the technical lead for and team lead for development for the water quality portal and I work here at the USGS Center for Integrated Data Analytics outside of Madison, Wisconsin. And we'll be talking here about the water quality portal. So I'm going to go over what basically the water quality portal is and its origins. Go over some of the benefits, give a demonstration, and talk a little and conduct both a demonstration of the portal and also demonstrate a few different ways that you can actually use the portal. So the portal background, where did it come from? One of the driving forces was what could be called from Leslie McGeorge in New Jersey, the New Jersey problem. New Jersey water data has been collected for years in a cooperative agreement with the U.S. Geological Survey. But what that meant was that data collected by the U.S. Geological Survey was deposited in NWIS, while data collected by the New Jersey Department of Environmental Protection was submitted to the STORET data system for the EPA. What that meant then was that when someone working for the state wanted to be able to collect all the relevant state data, they had to pull data from NWIS, they had to pull data from STORET. Those data were coming from, would be downloaded in different formats and then had to be recombined into one data set. That was laborious, it could be error prone, and it meant that it was really hard to get a full picture of what the water quality was in New Jersey. Other states had similar issues. So the National Water Quality Monitoring Conference took on this challenge, and there was a lot of discussion. And what ended up in part of that led to, in 2003, a memorandum of understanding between the USGS and the EPA that the USGS and EPA will deliver data from NWIS and from STORET in a common format to analyze and report on the state of the nation's water environment, provide a common basis for integrated data, water quality analysis and protection, and provide an information base for scientific inquiry about water quality. That led to, in 2012, a launch of the water quality portal. There was a series of mini portals that served similar data but separately in front of NWIS and STORET, and then finally everything was combined together in April and launched in April of 2012. Since then, the portal has served billions of rows of data and it continues to grow in use, and we'll go over some of that shortly. So, benefits of the portal. The portal reduces effort to use other data sources. So data sources, other organizations, other submitting organizations that are collecting water data in an area of interest may be collecting and saving that data in a really different format than what you may be using. Units, what a units column might be is different. All these different, how do you name a site? How do you describe a hierarchical, this organization collected this data at this site? How do you use Latin long? All these different pieces of information could be different. By collecting the data into multiple sources and combining it into that common format means that a single call, a single download can have data from dozens of organizations all in one place, or even hundreds of organizations all in one format right from the beginning, so you can get work on actually doing analysis of the data. There has been a lot of work done for describing data elements as part of, for example, the Exchange Network community has developed the water quality exchange format. And by taking advantage of that standards format, it makes it much easier to be able to get an overall idea of what there is and see essentially a marketplace, if you will, see all the different data available for a given area, see what you need for monitoring, see what you may need to go out and do more monitoring. And ultimately, it can support water quality-based decision-making. So by giving larger access to larger groups, sets of information, you can get better ideas as to how a given area is doing for complying with water quality standards. It may be able to identify hotspots that, as a regulatory agency, you may need access to, but you may not have actually done the sampling in a given area, but maybe another organization did. And eventually, it can lead to both developing and supporting the protection and restoration plans, and also supporting modeling for seeing what may be happening in the future. And ultimately, this is another thing, this is another benefit of the portal, is that by getting the data out in an accessible electronic format, we can get multiple people to be able to reuse the same data. So it can encourage organizations to collect better data, keep track of their data, because they want to be able to submit it to be able to be used by others. And you as an organization are then, it gets your data more visible and more usable, which can ultimately lead sometimes to more support for what you're doing. And also it allows for other organizations to make the most of their information and sometimes be able to do more monitoring because we're sharing effort. So ultimately, so the portal is part of how you can increase that access to the data for reuse. So the portal is pulling from 3 main data sources at this point. From the EPA STORET database, which is fed through the Water Quality Exchange using the WQX data standard, from the USGS NWIS database, and also now for about a year, the USDA STEWARDS database. All that information feeds into the water quality portal and then is fed out to the public through the water quality, again using the Water Quality Exchange WQX standard through the portal services. And the portal is architected such that additional data sources, other large federal data sets, for example, one we are working on is NOAA, can be added to the portal as well. The portal has access to over 250 million discrete water quality data records from over 2.2 million stations from all over the country, and actually a few different parts of the world as well. The data comes from, there's about, of those 250 million records, about 90 million are from NWIS and 162 million from STORET, and about another million from the STEWARDS data set. The federal data, then the partners and contributors really make a huge range of different types of data partners and scale. There's federal data partners, EPA, USGS, the Army Corps of Engineers, National Park Service, U.S. Bureau of Rec, all contribute data to the portal, either directly, as the USGS does, or via the STORET data exchanges, like the parts of the Corps of Engineers, National Park Service, Bureau of Rec. There are additionally over 50 different state agencies submitting data, over 130 tribes, and dozens of more of other organizations, county watershed groups, academics, volunteer monitoring organizations are all submitting data to the portal, mostly via the STORET data exchange. At this point, the portal primarily serves physical and chemical data, with biological data, both collection information and also eventually habitat metrics and indices coming soon. We anticipate those will be coming out this spring after a few different small, relatively, well, there were some delays that we were hoping to have these out by the fall. Portal usage, and this is actually the delay, that portal usage continues to rise over the last, this shows visits over the last 2 years, and over 500 visits per week go to the portal to access water quality data. And these are people actually going to waterqualitydata.us. There's also a huge portion of people and organizations accessing water quality data via the web services. You can see here, this is a graph of the last 6 months of use of the portal, and note that it's a log scale. Weekly rows of result data downloaded from the portal, and you can see early in the summer, there are not nearly as many users downloading data via via services. Sometimes only maybe a couple million result records a week were downloaded. But as use of different clients has really grown, now we're getting over 100 million rows a week regularly, both from the portal page and from the services. And this is leading to over 600 million records have been downloaded per month from the portal. Going back to the portal page itself, the portal page has been built using responsive design. It works on any device with a modern web browser. So you can use it on your computer, you can use it on your phone, you can use it on your tablet. So let's take a look at the portal itself. Do a demo of basic usage of the portal. Okay, this is the water quality portal, and this is the most important part here is the download data page. So the data page allows for a variety of different query options. You can query by location, for example, states. You can search for Wisconsin. You can search for multiple states. You can search for counties within those states. You can also search using geospatial locations. For example, you can use a location. For this one is using a geolocated from my browser. If you were on a phone, you could also use that. I could search within 50 miles of my location or 100 miles. And you can search by site type and parameter. So, for example, search for wells. Zoom in a little bit. So you can search for wells or streams. You can choose organization IDs. So, for example, if you were looking for Wisconsin DNR, you could get that information. You can also you can choose multiple organizations if you want. You can search by site ID if you know exactly what that site ID is. You can search for the hydrologic unit code if you're interested in a specific hydrologic unit code, and you can actually use wildcards. So, for example, if you were looking for the upper Mississippi, you could search for just the 0 for the Huck 4 and get that information. So you can search for up to Huck 8s here in the site in the Huck search. You can also search for, say, if you're looking for water samples, you can choose different sample media: water, air, biological, sediment, etc. You can choose by characteristic group. So, for example, inorganics or nutrients or pesticides, physical, all those types of basic information you can get from characteristic group. Or if you're looking for a very specific characteristic, you can search for that too. Just pulling from a much larger list, all the different characteristics that are available in the portal. Oops. Like that. So you can get all the different nitrate characteristics. You can see here that there's actually one of the questions or challenges that we have as the portal. As an aggregator of data, there are many different ways to write even just nitrate for collecting data, and this is a challenge that we are just starting to work on as we're tackling just getting the data available. How best to answer the question of there are 17 different ways that you can write just nitrate. What does that mean for my data? So you can also choose parameter codes if you're familiar with NWIS parameter codes, and you can choose and you can also filter by date ranges. If you're only interested in a specific database, you can also choose that. Once you've narrowed your choices, you can choose to either download the data, but maybe you want to see where that data is. So show sites on map, and you can see that what you're going to see here gives a quick preview, how many sites you're going to resolve, and then you can continue here. You can get the data on a map. See, another challenge of aggregated data sets, there are a few data sets that have probably extraneous pieces of information. I rather doubt any Wisconsin organization is actually collecting data down in the Galapagos. But you can zoom in on an area of interest. Maybe you're particularly interested in this area of the Nicolet National Forest. You can actually choose an area of interest and get back a set of sites that are interesting with your basic site information. And you can actually then download that information for this given bounding box directly from this site information pop-up. To go over a little bit more of the download information, you can download either site information or sample result information. And site information has all the different metadata about the site, where the site is located, what type of site it is, who the responsible organization is for that site, some basic well information. There's a little bit more well information coming out of NWIS than from STORET, and other information such as like that. Sample results are the actual sample result information for each site, and the site ID is the key piece that allows you to join those two these two tables or result sets together. And you can download your data either as a comment separated tab separated in Excel, or for site information, you can also download that information as KML. So just a quick demonstration on the site information. see that, and you can download that information. And there's your site information. Similarly, if you wanted to download the sample information for all of Wisconsin streams, I'm actually not going to download this because we've got a 9 million row table that we'd be pulling from, but you can get a basic information as to what's going on here. There is extensive documentation as to what these fields are in the user guide for the portal. It also gives basic information about how to use the portal as well. Different parameters, definitions of all the different parameters. And here you can get all the different headers for those CSVs or Excel documents and what they mean. And these are pulled from the from WQX and ultimately from the WQX outbound schema, which is a superset, an extension of the WQX schema that's used to submit data to the portal, to STORET via the data exchange. So let's go back from the user guide back to the portal itself. Another important thing to see is down here is the REST-like queries. So what does REST-like queries mean? REST-like queries means that for a given search, so if we were interested in Wisconsin, in this time we only wanted it in Dane County, and we wanted streams and wells. And we wanted nutrients. So we've built a somewhat complex query. You can show REST-like queries, and we've got the entire set information is right here. So that what this means is this is a URL, but you can actually paste just into your browser. You could paste into a script that that can make HTTP calls. You can paste in, or you could just hold on to it and run it again. And this script, this is just a definition of the web service call. There's nothing special about this, and this will work over and over and over again. It's not information from your session or anything else. So you could actually just copy and paste this information, and there's your station graph. There's your station file. And there's still a good number. There's a good 464 rows of stream data in Dane County, Wisconsin that samples for nutrient data. And there's a similar for results. So you're pulling off of the result endpoint instead of off of the station endpoint. And the web service, this is a core piece of functionality for future use of the portal. And as you can see, this data, the front end that you see here is just a thin layer on top of the web service. And again, there's an extensive web service guide that you can, if you're a developer and you're familiar with building web services, interacting with web services or APIs, you can use this to build your own APIs using using your own tool. And this service can be considered quite stable. We may eventually deprecate it or release an alternate version, but that will be years from now and with years of warning. So that's a basic rundown of the use of the portal. Let's go back to once you have that information, what can you do with it? So there's another portion of functionality that the portal has, that we've built as a portal team that's outside of the portal, and that is clients. So we have an API, and maybe you're familiar with a tool such as tools such as R or Python, which are programming languages that are used for data analysis. What we've written is a few different clients, which is a bridge between the API, the Water Quality Portal services, and those external tools, so that someone who's familiar with R, the statistical language, can grab the Water Quality Portal client and just get started doing analysis. They don't have to do anything. They don't have to figure out how to interact with the API itself. The client takes care of that. And the Water Quality Portal has two different clients. One called Data Retrieval, which is for R, and also we have PyWQP for Python. So let's just take a quick look at what you can do with R. So USGS R is a repository on GitHub that's supported, that is part of the USGS development community, and has a few dozen different packages, and these continue to grow as R is beginning to be supported as the primary statistical tool for the USGS. And one of the tools that's supported by both the USGS and the Water Quality Portal is called Data Retrieval. And so data retrieval is available through the CRAN repository and also directly through GitHub. And it has a number of different functions, as you can see here. And one of those is to be able to pull data from Water Quality Portal into the actual into R. So what does this mean? What does that mean? What can you do with that information? So once you're into data retrieval, that just gets you into R, but it doesn't get you that much information. We've also built just some demos, or tools used to actually explore data exploration. And we'll just go over a couple of examples here right now. So for example, say if you're working in the in the western Lake Erie basin, and you're interested in all the nutrient data that might be available. Well, western Lake Erie basin, it crosses the borders of 3 states. And so it requires, if you pull data from the portal, you can see that there's actually data from 11 different organizations and a few hundred different sites. And it has a very specific geographic distribution. So to be able to get a basin scale idea of what's happening, you really need to be able to dive in to use data from many different organizations. Maybe you want to dig deeper. So maybe you want to know not only how many sites in the western Lake Erie basin have been sampled for nutrients, but how many have been sampled specifically for phosphorus. Maybe you're interested in not only just for phosphorus, but you're a modeler. and you want to know which sites have more than 50 phosphorus samples with at least 10 of those samples after the year 2000. And there you go. So this gets you information, so then you can say, okay, these are the sites that I can use to build eventually into my overall model, for example. But maybe you're not interested in the Western Lake Erie Basin, but you want to use the data exploration, but you're interested somewhere else. Well, with only changing 2 lines of code, instead of saying read WQP data 0410, you want it to be read WQP data 0207. If you're, and instead of what WQP sites 0410, you want what WQP sites 0207 star. And there we go. We've changed the Potomac River. Again, data is available is across multiple different jurisdictions, collected by multiple different agencies. We also have a similar client with similar functionality with the Water Quality Portal Python client, which is available also on GitHub on the USGS STEWARDS GitHub repository as PyWQP. And this will be also up on PyPy in the relatively near future. What we expect to see from the portal for FY15 activities are identifying additional data partners and sources. For example, we are starting to talk with NOAA and getting some of their data in, and also possibly making water quality portal services available through some of NOAA's cataloging tools. Starting to dig more into data opportunities to improve data quality and provide tools for assessing data quality. We're going to be serving biological data out of the portal, improving the mapping interface, and hopefully starting to touch on integration with the NHD, and starting to dig into what we're doing with continuous data as sensors and nitrate sensors and other types of sensor information is really starting to grow. And we expect to have multiple more webinars and demonstrations for this types of tools. So any questions you can put toward me or Charles Kovach, the EPA lead for the portal. Thank you.